actually write the algorithm. Just because you know how to do something doesn't mean that you can write an algorithm to help the computer to automate the process, right? So it's that process that is the most difficult to explain, is how do I explain it to the computer in a very concise and yet precise way so that the computer can do also that. All right, it's 7 o'clock. I'm going to get started, even though I think we're missing maybe a quarter of the class at this point. Okay, so what I want to do is I'm going to show you one of the apps that I'm writing, because I just want to show you the complexity of software, especially for people who have no prior experience of writing computer programs and software and stuff like that. So I'm gonna give this a try and sign into my App Inventor site. Has anyone tried to write any apps for Android or iPhones? Nope. Okay.
I used your MIT Inventor. Can you show us?
Yep. So how do you like it?
Pretty cool.
Yep. Oh, it crashed. Okay. Let's try that again. Actually, I know why it's, well, maybe not, because it was working the other day, so we'll give it another try in the background. All right, so as far as this class is concerned, we are now talking about returning a value or returning values from a subroutine. And in terms of the notes, where you can find information about that, it is in, we are basically at this point in section 7, which is the last section of the notes regarding subroutines. So we're almost done, okay? We're almost done, but returning a value can be confusing, especially in the case of recursion. So that's what, this is something that we'll take a look today, is how to do recursion, and also how do we use the result of a invocation as a parameter of another invocation. Last time I already showed you guys how to do 2 invocations. Remember, 5 plus 5. Okay, invoke 5 in parentheses plus invoke 5 also in parentheses. So what we'll do today is to do something a little bit different. We'll involve parameters in this case. And as usual, I'm going to use a sample program to illustrate the concept and then trace it right after I present the algorithm itself. So I'll define sub, and we'll just do add here. Okay, so the subroutine itself doesn't do anything that's particularly challenging or interesting. Add has 2 parameters. It has by value x, by value y, and all it's going to do is to return x plus y. And define sub. Just so that we warm up, because today is Tuesday, we haven't met for the last 5 days. So just for warm-up purposes, I'm going to write a very simple program first, and then we'll make this a little bit more complicated. We'll have define sub main, and it has 1 local variable. Let's say it's called n, and then we'll have just n gets invoke add, and then we'll specify 2 values to add. We'll specify 3 to specify x, and then we'll have 7 to specify y, and define sub. So this is just a really simple program to illustrate the concept of returning a value, and then from here we'll make it a little bit more complicated. All right. Are there any questions at this point about this sample code or this pseudocode program? Okay. No questions. All right. I'll give these line numbers, and then we'll start tracing it. Okay. We don't need comments because there are no conditions to evaluate in this case. So we'll start with line number. There are no global variables. Okay. How do I know there are no global variables? In subroutine add, we have 2 names that we refer to, x, y. X is a by-value parameter, and so is y. So they cannot be global variables. In subroutine main, I have the name n, but n is a local variable, so it cannot be a global variable either. So we have no global variables. The precondition has nothing to say, because there are no global variables. We start execution on line 10. The first thing we do is to establish a return line number. Now, when do we decide when to use a return info column and when do we use a return line number? Depends on the subroutine. If the subroutine is returning a value, we use return info. If the subroutine does not return a value, like main in this case, we can use return line number. Okay? So that's how we can decide which way to go. In this case, it's a return line number. We'll just put post here because post is the line right after line 10. It has one local variable n, which always starts with an unknown value. And then we continue execution on line 8. And here is the first part. The first part of the question is, what do we do on line 8? Okay. Well, it's a combination of concepts that we have learned up to this point. On one hand, we have a subroutine that returns a value, which is add. And on the other hand, it is also a subroutine that takes on parameters. So now we are combining those two concepts, returning a value and also having parameters. But that's okay, it's not a problem because those two features do not conflict with each other at all. Because it is returning a value, I have to use return info in this case. But because it has parameters, I also need to allocate two more columns, one for x and one for y. What do I put into column E? What value should I store in column E?
3.
3, exactly. And then y?
7.
7, okay. So that part is pretty much the same way, when we pass by value, same mechanism, nothing has changed. When we specify the return info cell, we have to store enough information so that we can continue execution after the subroutine is done. So in this case, on line 8, I cannot just say, go back to line 8 or go to line 9 because neither one is entirely correct. I have to say go back to line 8. But what else on line 8 do we have to do? Well, the left-hand side still needs to store the value on the right-hand side. The right-hand side in this case is going to be resolved by the time we return. The question mark is taking the place of the invoke itself. It is a placeholder for the return value. Yep.
Shouldn't it be 2 question marks? Since there's
No,
2.
there's only one because there's only one invoke.
But there's 2 parameters?
The parameters are already specified in column E and column F.
Right, but they're 2 separate variables, so wouldn't you have to add them together? So that
No.
No?
No, there will be one single value that takes the place of the invoke itself. And that's why there's only one question mark. In fact, if your return info cell has more than one question mark, something is not right. Okay, it should only have one and only one question mark when you set it up. Okay, because it's a placeholder for the return value. You can only specify one return value. And therefore, you can only have one question mark. Okay. So we'll take a look at what we are going to do with this kind of strange looking thing here when we get into the subroutine. The subroutine doesn't do much. Line 4 is the only thing we're going to do. So the first thing we want to do on line 4 is to evaluate x plus y because that specifies the value that we are returning. Parameter x has a value of 3, parameter y has a value of 7, 3 plus 7 is 10. The value that we are returning is therefore 10. What do we do when we return a value of 10? We are going to copy and paste the return info cell, change the question mark to the value that we are returning. Because after all, the purpose of the question mark is simply as a placeholder so that we know where we will specify the return value when we get to the return statement. Are we doing okay? Yep, go ahead.
Well, shouldn't you have a new place, a new return line since you're doing add? Because when you're doing when you're invoking main, you're doing a new return line. But you're invoking in 8, you're invoking add. So shouldn't you have a new return line? Or
It's not a return line number because I can no longer use a line number to specify where to continue execution. Because I cannot use a return line number 8 Because if I did that, I would be doing the whole thing again. It becomes an infinite loop. If I specify return line number of line 9, then I will be skipping the assignment statement, right? So I cannot use either line 8 or line 9. I have to use return info, which specifies, yes, we have something else on line 8 to finish before we can move on to the next line. Yep.
First, you're trying to ask, wouldn't you do 2 return infos for the question mark to n and the 10 to n?
I have to do this because I'm going to specify what the question mark is. Now, I could have just changed the question mark to a 10, but that won't be, it's not a trace anymore because I'm modifying something that I created earlier. If I do it this way, it becomes a trace because I know at what line do I change the question mark to an actual value. So that's why we are copying and pasting it and then changing the question mark to a particular value. So it's really just for a complete record of what happened while we execute the pseudocode. All right? Am I answering your original question or not?
Kind of, sort of.
Kind of, sort of. Okay, that's a double vague statement. Okay, so maybe when we go through a few examples, it will be more clear. Okay, on line 5, we have n defined sub, and it's going to do pretty much the same thing as every subroutine. When we are at the end of a subroutine, we have to find out, okay, but what else do we have to do after the subroutine is done? In this case, I'm going to copy and paste the entire return info into column A. The reason why I'm doing that is because I don't want to just say line 8, because if I just say line 8, I'm not quite sure what else on line 8 I have to do. This way, I know exactly what else on line 8 I have to do. Are we doing okay so far with this concept? Okay. But after I make use of the return info cell, just like with the return line number, all of these columns are useless to me at this point, so I'm going to deallocate every single one of these, and now I'm continuing execution on line 8. But this time, when I'm on line 8, it is equivalent to n gets 10, because the invoke add action is already done. The whole invoke is now resolved to a single value of 10, so I'm really just storing the value of 10 to n, which means column C is updated to a value of 10 after this line 8 executes. And I can move on to line 9 in this case. Line 9 is looking up the rightmost return line number, which tells me I have to continue execution at post. And then after I make a note of that, I have no use of these 2 columns anymore, and do a strike through to represent they're now gone. And I'm done with the entire algorithm at this point. Any questions about this program at this point? Yep. Mm-hmm.
Since we're running n within main, it's not. How could it get a value from outside the main subroutine?
It's because the invocation of add resolves to a single value.
Yeah.
N gets a value when we execute line 8, but that's perfectly okay because line 8 is a part of the main subroutine, and the main subroutine has visibility of its own local variable n in this case.
But line 8, we actually skip main to execute the sub add.
Which row are we talking about? Are you talking about row 5 or are you talking about row 9? Because this row and this row are both line 8.
Yeah.
One is referring to the first time we get to line 8. The other one refers to the second time we get to line 8 when we return from the subroutine add.
I'm talking about number 5.
Row 5? Okay, so let's look at row 5 here. Okay, so when we execute line 8 the first time, which is represented by row 5 in the trace, that line looks like exactly the way it is represented here. I cannot perform the assignment action because I don't know how I'm supposed to change n at that point. So I have to invoke add first, to figure out what is the return value of add. And only at that point I can say, now we can continue with the rest of that line, which is simply to change variable n to the value that is returned by add. Any other questions about this one? If you have any questions, this is a good time to ask, because the next one is going to be a little bit more complicated than this. Yep.
Why wouldn't you put that into that in line 9? How come you didn't put that into like a comments column instead of on the line number?
Could you ask that question again?
You put it in the line number instead of in the comments column.
That's correct. Because the line number column helps me identify which line am I executing. So row 9 is telling me exactly that I'm executing the rest of line 8. But it is not the same as the line 8 in the pseudocode, because the invocation is done already. It is now resolved to a single value.
I guess what I was just saying is that everything up to today, we've always had a comments column.
No, that's not true. The comments column is only needed when we have a condition to evaluate. That's what it's for. The comments is really just for representing side effects that cannot be represented in any of the other columns.
So this would be more of an assignment, or what do you call this thing? I guess
It is it's letting me keep track of what else on line 8 I have to do.
something new. I guess then.
It is something new because returning a value is a new concept. Yep, there was another hand. Oh, you guys don't have a question anymore? Okay. Are there any other questions about this one?
I mean,
Yep.
I guess I don't. Hopefully, I'm not jumping ahead, but are we
Go
gonna
ahead.
cover, like how we return a value outside of the
Subroutines, like, so at the end of the algorithm, you'll actually maintain a value. Or?
At the end of the subroutine,
Okay.
you have a value so that whoever is invoking the subroutine can make use of the value right away without having to store it into a variable first.
Okay.
If you use pass by reference, yes, you can achieve something that is similar, because passing by reference allows a subroutine to change a column that does not belong to the subroutine, which is great because now you can pass a result back to something that invokes the subroutine. But the problem is it's inconvenient, because in order to make use of that result, you have to store the value into a variable first and then use the variable again in something else. This allows you to make use of the result right away without having to store it somewhere else. So it's more or less a convenience feature. In other words, if we do not have the concept of returning a value, it's not the end of the world. We can still do just about everything that we need to do, but it becomes very cumbersome that way. So this is a nice, convenient way to do certain things. Okay. All right. So any other questions about this particular example? No other questions? Okay. I'm kind of debating whether I should give you, this as the next, example, or I have two alternatives. Okay. I think I'm going to continue with the add subroutine. Okay. So I'm going to do the same thing here. Define sub add by val x by val y. So all of these are the same. I could have just copied and pasted. It's okay. Retyping doesn't take that long. So the same subroutine, and then we have define sub main, and this time we have a local variable, local n, just like last time, except this time n is going to get something a little bit more involved than last time, but not by much. Invoke add, and we'll specify 3 again to specify x, no change from last time. But to specify the value of parameter y, I'm going to use this. Invoke add again, and this time I'll use, 2 goes to x, 5 goes to y, and then the result or the return value of this invocation of add is in return used to specify parameter y for the other invocation. So we have a nested invocation in this case because I'm using the one invocation to specify the value of the parameter of another invocation. Okay? And that's it for main, and define sub, and invoke main. In other words, this program is kind of similar to the one that we looked at already, but with one little thing that makes it very different, which is we use the invocation of a subroutine to specify the value of a parameter to another invocation. The first question I want to ask you is how many columns am I going to use up in this case? Let's take a look at the previous one first. Okay, this is the one that is previous, and that is the trace we used up to column F in this case. Okay, when we did everything at the deepest level, we have to use column F. What do you think? How many columns do we have to use with the new program that looks like this?
One more.
Hmm?
More.
One more.
I'll give you same. Okay, we have same. What else? I'm gonna take all the bets. Okay, the answer is the same. Okay, we are not using a column more than the previous one. Okay, and the reason is I'm only dealing with one invocation at a time. Okay, that is the reason. Okay, so let's trace it and find out why that is the case. Okay, and this one is a little bit harder to read because of that. I'm going to change a little bit here. I'm going to specify this cell to wrap around, so that way it's not going to take up as much space horizontally. Okay, so that gives me a little bit more space. And we'll do the same thing here. Line number, there's nothing to say about the precondition. We do not have global variables in this case. We start execution on line 10. We invoke main. We have to remember where we're supposed to go back to continue after main returns. That turns out to be post because there's nothing else to do. And then main has a local variable n, which starts with an unknown value. So all of this stuff is basically identical to the previous trace. No changes up to this point. In main, we start execution on line 8, which is the only line that does something in main. And here comes the question. We know that it is supposed to be a return info in this case because, hey, we have to get back onto line 8 to finish up some operation. So now the question is, what am I going to write in this particular cell? In other words, what do I write so that I can remind myself what else on line 8 I have to do when I'm done with the invocation of a subroutine? So here's the question. Here is the real question. If I look at this line here, okay, it's kind of convoluted, but let's look at this bar up here because it's still linear and it's easy to read. I have two invocations to choose from. I can deal with this invocation first, or I can deal with this invocation first. Which one should I deal with first?
Middle.
The one that is inside, innermost in the parentheses, right? It's just like when you evaluate an expression, you always go for the innermost portion first in terms of the nestedness of the parentheses. And it's the same thing here. I cannot deal with the other invocation until this one is done, because to deal with this invocation of add, I need to know what value I have to use to specify parameter y. But I cannot know that until this invocation is done, because the purpose of this invocation, the one that is highlighted, is to specify the value of parameter y of the outer invocation of add. So that's why I have to deal with this one first. Now, in the representation of return info, whichever invocation you're dealing with is the one that turns into a question mark, because the question mark is representing a placeholder for the return value of that particular invocation. So in this case, that is going to be that will turn into a question mark. So in the trace, this is how I will go ahead and represent what else I have to do, which is saying I'm still going back to line 8 because there are things on line 8 that I have to do. The assignment to n still has to be done, but before I can do that assignment, I have another invocation of add, and this one has 3 specifying x and the current invocation to specify the value of y. That is how I am going to represent the return info here, so that I can keep track of what else I have to do, what else do I have to do when I get back from this invocation of add. Are there any questions about how I'm using, why I use this representation for this return info cell? Oh, okay, you're just scratching, okay. Any questions? Now remember, in the return info cell, you should only have one and only one question mark. Okay? Never 2, just 1. Now, of course, when I'm invoking add, I need to specify, parameter x and parameter y. What should I put here in column E? 2, and then in column F? Exactly. Okay? Because I'm dealing with the inner invocation of add, which specifies 2 to go to x and 5 to go to y. And here I have the first invocation of add. I continue execution on line 4. Line 4 has to evaluate x plus y first. X plus y is 2 plus 5. 2 plus 5 is 7. I am effectively returning a value of 7. What do I do when I return a value? I'm just changing the placeholder to the value that I'm returning. In this case, I'm returning a value of 7. So the placeholder, which is the question mark, is changed to the value that I'm returning. And that's all I'm going to do with the return statement. When I execute the return statement, I'm just changing the question mark to a particular concrete value. That's all I'm going to do. Nothing else. I'm not invoking add again here. I'm not doing the assignment here. Nothing. Just changing the question mark to a value. Then we continue execution on line 5. Line 5 is the end of the subroutine add. So at this point, the first thing I want to do is to figure out, after add is done, where am I supposed to go and what do I have to do right after this? That's the whole purpose of the return info cell. So this is the same thing as last time. I copy and paste the entire return info cell after the question mark is resolved to remind myself what else do I have to do when I get back onto line 8. But once I make use of that information, these columns are no longer useful to me anymore, and they will all be deallocated. Got? And now we continue execution on line 8. But line 8 doesn't quite look like the original line 8 anymore, because the innermost invoke add is already done. It is now resolved to a single value of 7. What else do I do on what else do I have to do on line 8? Can I do the assignment now? Can I change n? No, I don't know what value I have to use to change n. So what do I do next? I have to invoke add again. Can I y used to have an unknown value. Can I invoke add now at this point? Yeah, because that whole invocation, the innermost invocation of add, has already resolved to a single value of 7. So now I can say, okay, we want to use 3 to specify parameter x and 7 to specify parameter y. Hey, I can actually go ahead and invoke add now, the outer invocation. So we'll do exactly that. We'll reallocate column D for return info, and this time it becomes n, line 8, n gets the value of this particular invocation. Parameter x gets a value of 3 because that's how the invoke statement is written, and parameter y is getting a value of 7 because it is using 7 to specify parameter y. Are we still doing okay so far with this code, with this trace? Okay, once we set up all the columns, we can continue execution in the subroutine, which is on line 4 only. And this time we are adding x, y. X has a value of 3, y has a value of 7, x plus y is 10. We're returning a value of 10. when we return a value of 10, we just copy and paste the return info cell, change the question mark, which is a placeholder of the return value, to the value that we are actually returning, which is 10 in this case, and we are done with the return statement. Then we move on to line 5. It will do exactly the same thing as last time. We look up the return info cell. It tells us, hey, you got something else to do on line 8. Fine, we'll copy and paste it, make a note of it. And then after that, we have no use of these columns anymore because they are, this invocation is done. It has concluded. So once again, we get back onto line 8. This is the third time we get to line 8. But this time, when we get back to line 8, it becomes a simple assignment statement, which is basically saying, oh, the right-hand side is a single value of 10, and the left-hand side is n. Do we know how to do that? Sure, we're just changing n to 10. N is column C in this case, change it to 10, and we are now finally done with line 8, and we can now move on to line 9. Line 9 is looking up the rightmost return line number, which tells me to continue execution at post. Then we have no use of these two columns anymore because the invocation has concluded. So we mark it as the allocated, and we're all done. Are we doing okay so far with these phrases? So this is, go ahead, I heard a question. Okay. So this is why I said earlier, the whole idea of returning a value is so that you can put an invocation of a subroutine where a value is expected. Now it can be a part of, it can be the right-hand side of an assignment. It can be a place to specify a value for a parameter. It can even be in a conditional statement, the condition part of a conditional statement. So we'll take a look at the next example, which is exactly that. Okay? So here comes the third example today to illustrate the concept of returning a value. So we'll just go ahead and say define sub. Let's see. I'm just debating whether to make it, complicated or make it, simple. I'll just make it simple in this case. I'll just say yada yada. Okay, yada yada. Okay, there we go. Okay, because I don't want you to know what it is supposed to do, so I'm going to use some word that has no particular meaning, unless you watch Seinfeld a lot. And all it's going to do is to return true. Okay, and define sub. All right, this program is not going to be a very exciting program, but nonetheless, I want to use it to illustrate some of the kind of more tricky way of using a return value. So now we have main here, and this time I don't even bother to have any local variable. I'm going to say this: if invoke yada 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 yada, then we print something. What is the other phrase in the Seinfeld that has the same meaning as yada yada? I cannot remember. I have to watch the episodes again. I'll just print Seinfeld. Okay, Seinfeld. No soup for you. Okay. That's all I'm going to do. Okay. Let's make an else here just to make it more exciting. It's not going to be exciting anyway. Okay. So, double dipping. So basically, yeah. Some of you probably remember the episode where George double dipped in a party and was confronted by one of the guests.
Are we still going to look at your thing on the MIT thing too? Are we still going to look at the MIT thing?
Yeah, we can take a look. Sure. And we'll finish this one first, and then we'll also finish factorial. So we'll revisit factorial, but this time make use of the concept of returning a value. All right, so we get this. And let's go ahead and trace it. All right. This time we do need a column for comments because we have a condition to evaluate in a conditional statement. We have line number, the precondition got nothing to say because we have no variables of any kind. No parameters, no variables, nothing in this case. On line 11, we invoke main. We have to remember to return line number because main does not return a value. Is post and has no local variable, so this is all that I need to do when I invoke main. We continue execution in the subroutine starting on line 5. Okay, now we have a problem here. Okay, what do we do on line 5? Because that seems kind of strange because it's a conditional statement, but I cannot decide where to go yet because I don't know whether it is true or false. If it is true, we go to line 6. If it is false, we go to line 8. So I can't decide where to go first because I need to first invoke the subroutine called yada yada. And that's exactly what I'm going to do, is to invoke yada yada. On line 5, I'm invoking yada yada first. But yada yada is returning a value, which means I have to use return info instead of a return line number because I have to go back to line 5 to finish up some operation. So I have to use return info in this case, which tells me I have to go back onto line 5. And I'm just going to type the entire line 5 the way it is, except the invocation of the subroutine is replaced by a single question mark as a placeholder. So in this case, it becomes if question mark then, because the invocation is the entire thing inside the parentheses. Are we doing okay so far with this example? Did I do anything that is different from all the previous examples of using returning values? Not a single thing. Even though this time the invocation is inside the condition of a conditional statement, I'm still doing exactly the same thing. Okay, so I'm hoping that you guys can see that the mechanism has not changed. Even though where I place the invocation has changed, the mechanism has not changed. Okay. All right, so once I write down the return info, I can continue execution in yada yada. So on line 2, I execute return true. So true is the value that I'm returning in this case. So if I'm returning a value of true, I just blindly go to the return info cell, copy and paste it, change the question mark to the value that I'm returning. In this case, it's true. And I'm done with the return statement. Because I have just specified what the subroutine is going to return, what is the value that should take the place of the invocation itself. On line 3, we do the same thing as usual. We have to figure out what else do we have to do after the end of this subroutine. That's exactly why we have a return info cell here. We have to go back onto line 5, and apparently it is a conditional statement and we have to do something on that line. But I'm just going to make a note of that we have to go back onto line 5, and that's what we need to do when we go back to line 5. And that's the line 3's job, it's just that. Plus, to deallocate column D, because it is allocated on a per invocation basis, and this invocation of yada 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 has concluded. Now we're back onto line 5. Oops, I put in the wrong column. Thank you. Okay. Sorry about that. It should be in the line number column because the line number column is the one that tells me where I'm executing in the program. I'm now executing line 5 again, but this time I know what it's supposed to do. It's using a value of true as the condition. So what do I do in the column for comments? That's easy, right? True is true. Because before I take a branch, I have to say what is the condition, what is the value of the condition of a conditional statement. In this case, it resolved to a single value of true. Well, if the condition is true, we continue execution in the then branch, which is line 6 in this case, and it prints, it prints Seinfeld, and we're done with the conditional statement. We get to line 10. Line 10 looks up the rightmost return line number in this case. It tells me to continue execution at post, and then we have no use of column C anymore. And we are all done. Are there any questions about this particular trace? Go ahead.
Just one little thing. So if the condition you're evaluating is just true itself, you're always going to have to execute the then?
Right, correct. Whenever the condition is true, you evaluate, you continue with the then branch. But in this case, the subroutine could have returned false too. So in that case, we'll go to, well, not the way I write the subroutine, but until you return from the subroutine, you do not know, whether you have a true value or a false value. Okay. And there was another question.
It's just probably technicality. Should we write true is true, or return value is true, or invoke yada yada?
It is just true is true because you can see inside the parentheses it's just the value true itself. Anything else? Any other questions? No? This is all good? All right. So I think we are ready for factorial again. But this time making use of return statements. Right. And you guys will like this one. Because it is the most concise and the cleanest way to specify factorial. And this time I'll just use fact to represent factorial because otherwise the width of the line would get kind of wide. Okay. It has a single value. It has a single parameter passed by value, which is n, because we're trying to find the factorial of n in this case. And this is the rest of the code. If n equals to 0, then return 1. Else, now this is the really, really cool part, is I can do the rest on a single line. Because I can say return, and let me just think about how to do this. I have two ways to do it because multiplication is commutative. I just want to find out, well, I'll do this. I'm going to invoke factorial on the very same line as the return statement. Invoke factorial, we specify n minus 1 to the parameter n in this case, and if, and define sub. That's my new factorial subroutine. It is the shortest version of all the versions that we have gone through. And then we have the usual define sub main. And for this one, I'm not going to use any local variables to store the value. I'm just going to print out the factorial of 3 in this case. So I would just say print invoke factorial. Go ahead and find the factorial of 3. And define sub, invoke main. And we'll go figure out what this subroutine or what this pseudocode is going to do. Okay. So once again, the purpose of returning a value is so that we can make use of the result of an invocation of a subroutine, which is this part here, right away within the same, in this case, multiplication. I don't need to store the factorial of n minus 1 to some variable first and then say, return n times that variable, which is kind of neat because I can basically make use of the result of the invocation of a subroutine right away in place and not having to use a variable to store it first. Okay. Let's go ahead and trace it. Before we trace it, are there any questions about the pseudocode itself before we start the actual trace? No questions? Okay. Let's go ahead and get started. We do need comments because it has a condition to evaluate on line 3. We have the usual line number. We do not have global variables in this case, so the precondition really has nothing to say. And then we start execution on line 12, invoking main. Main only needs a return line number because main does not return a value, and the return line number is post. Yep, go ahead.
In line 3.
On line 3,
Could you do it both by doing n equals 0, and also can you do it in another way by doing n equals 0 too?
In this class, equal means checking for equality. It does not mean assignment.
Okay.
Yep. And that's the whole purpose why we have a left arrow to mean assignment, so that there's no confusion of when are we changing the left-hand side and when are we actually comparing. When you see the equal symbol in this class, it is always comparing. Okay. All right. Now we continue execution in the subroutine that we are invoking, which is main. We are now at line 10. Line 10 eventually wants to print something. It wants to print a number to the screen, but I cannot do that yet because I have to first invoke factorial with 3 specifying n. So when I invoke factorial this time, I have to use return info to remember what else am I supposed to do when I get back onto line 10. When I get back onto line 10, I still have the print to do, but the value that I'm supposed to print should be resolved by the time I get back onto line 10. Is that okay so far? Is that making any sense? Okay. But since I'm invoking factorial using 3 to specify n, I also need another column to represent n as a by-value parameter, which is a value of 3 in this case. After I set up both columns, d and e, I can now continue execution in the subroutine starting on line 3. Line 3 checks n equals to 0. In this case, it is false, so I have to continue execution on line 6. Line 6 may look kind of confusing because we have both an invocation and a return on the very same line. But what you need to do is to figure out, but in which order do we do these things? Is it time to perform the actual return action at this point? Nope, this is the first time I get to line 6 in this invocation. I'm not quite ready to do the return. Can I do the multiplication? Nope, because I cannot do the multiplication without knowing the right-hand side of the invocation, of the multiplication. So what can I do at this point? Subtraction first, okay, so I subtract 1 from n, or we compute n minus 1. In this case, n is 3, n minus 1 is 2. What do I do with that 2? Now that I know n minus 1 is 2, what do? I do the invocation, right? I can invoke factorial again at this point. So whenever I invoke factorial, which returns a value, I need to allocate a column for return info. And in this case, we are returning back onto line 6 to continue and finish up some operation. The return action is not done yet. The multiplication is not done yet. And by the time we return, the only thing that is done is resolving the value on the right-hand side of the multiplication. That's the only thing that we would resolve at this point. But since we're invoking factorial, I also need to specify what is parameter n. In this case, we already just talked about it. It is 2. And now we have set up the 2 columns for the next invocation. Once I remember where I'm supposed to go back to and also the parameters, I can now continue execution in the subroutine that we're invoking, which is factorial, starting on line 3 again. N equals to 0 is false, so we go to line 6 again. So I'm hoping you guys are starting to see the pattern here. Yep.
In the number 10, the line number 10?
Row 10.
Row 10, yeah. The line prior to that, 9. Is it possible to write 6 return 3 multiplied by question mark?
No. No, because the one thing that we are trying to do is to resolve the question mark. So we have to let n remain as n and not turn n into 3 at this point. There's a reason why we do that, because it is possible that when we're invoking the subroutine, we can potentially pass n by reference to it. So in that case, it's going to be tricky because in some compilers, it would just use the current value of n. In some other compilers, it can evaluate n after it returns from the subroutine, so it would have side effects. And by the time you come back, n is not 3 anymore. So it is possible that a subroutine can do that. But not in this case. In this case, if you just write down 3 times whatever question mark, it's going to work out the same way as doing it this way. Okay, so now we're back on the line 6, and you probably know what's going to happen here. We'll set up the columns pretty much exactly the same way, except n is now, instead of 2, it is 1, because it is 1 less than what in the previous invocation. All right. Okay, now we are going to split the screen vertically, just so that we can see that part also on the screen. All right, now that we set up column H and column I, we continue execution on line 3. N equals to 0 is false again. We go on to line 6, and when we get to line 6, we will do pretty much the same thing, right? Copy and paste this, except N now has a value of 0.
Intended.
Oh, okay, just hold on a second here, and I'll pass that row sheet. Is it this one? Yep, it is. Thank you. All right. So now we have column J and column K representing the return info cell or the return info and also the parameter N. And then we continue execution on line 3 again, but this time N equals to 0 is finally true. Okay, and therefore it is now changing the path of what we do inside the subroutine. For the first time, we execute line 4. Okay, line 4 is returning 1. Okay, it cannot be any more clear than that because 1 is just 1. It is the value 1. So what we're doing is we are going to copy and paste the return info cell, which is this one here. And then we say, oh, okay, we know exactly what value we are supposed to return for this invocation, and only for this invocation. We have many invocations at this point, but we can only resolve one question mark at a time. So we're only resolving this one to a 1, okay? And that's it, okay? I'm not going to change this whole thing to, oh, it is 0 because n times 1 is 0. Nope, we don't do any multiplication. This is not the time to do it. The return statement only does one thing: change the question mark to something. That's it. Is that okay? Okay. So we don't do anything about line 6 at this point. We're just changing the question mark. And then we move on to line 8, because now we're out of the conditional statement. On line 8, it is the end of the subroutine. We got 2 things to do. One is to look up the return info cell and say, okay, now that I'm at the end of the subroutine, where do I go next to do some operation? Let's go to line 6 and finish up whatever is left on line 6, which is this part here. So I'm just copying and pasting that onto column B. And it's okay like this. I'm not going to change the size or the width of the column because it's not interfering with column C at this point. Once I make note of that, I have no use of the 2 columns allocated for this particular invocation, and I'll mark these as deallocated. And then what do? Well, we're now back to line 6. Great, but column J and column K are now gone. So we have to go back to column H and column I as our current context when we execute line 6. That means when we execute line 6, are there any more invocation on line 6 for me to do? No, it's just n times 1. But which n are we talking about? We're talking about column I. Column I has a value of 1. 1 times 1 is 1. So when we execute line 6, in this case, we are returning a value of 1, which means we will look up the return info cell, the current return info cell, copy and paste it, change the question mark to the value that we're returning, and that's it, okay? Nothing else. After we are done with line 6, we get out of the conditional statement when we get to line 8. And once again, on line 8, we do pretty much the same thing. We look up the return info cell, make a note of that so that we know where we're supposed to continue execution and what else we have to do on that line. And then we have no use of column H and column I anymore. Deallocate both of those columns. And now we are continuing execution on line 6, except column H and column I are now gone. So my current context becomes column F and column G, and I have to compute n times 1 using n as column G. Column G has a value of 2. 2 times 1 is 2. I am effectively returning a value of 2. To return a value of 2 simply means that I have to go to the return info cell, copy and paste it, change the question mark to a 2, and I'm done. Okay. Now, it is very important to understand what we are doing with column B and what we're doing with column F, okay? Because it looks awfully confusing because we have return n times 1 on one side and then we have return n times 2 on the other side. What is going on here? Column B is telling us where we are in the execution of the program, okay? It's kind of like a bookmark saying, okay, this is where we are. We are doing this right now. Column F is reminding us what do we have to do when this invocation of the subroutine is done. So we are just preparing ourselves for the return at this point. Okay? All right. So now we continue execution along line 8 because line 6, line 8 follows line 6. So now we are on to line 8. Line 8 is going to do the same thing at the end of a subroutine just as all the other times. We look up the return info cell. It says, oh, okay, we have to continue execution on line 6, and this is what line 6 should look like at this point. Fine, make a note of that. And then we have no use of column F and column G anymore. Copy and paste it, strike it through, and now we move our context back to column E and D and E. So I'm going to get rid of the split screen here. I'm executing line 6 again, but column E is my n at this point. I have to resolve the multiplication first, which is n times 2. N is now column E, which has a value of 3. 3 times 2 is 6. So right now, I'm effectively returning a value of 6. To return a value of 6 means I look up the return info cell, copy and paste it, and change the question mark to the value that I'm returning. In this case, it is 6. Then I'm done with line 6. I move on to line 8. Line 8 will do exactly the same thing. We have to figure out, make a note of what else we have to do, where to continue execution. We continue execution on line 10 according to my return info cell. And after I make note of that, I have no use of column D and column E anymore. Mark those as deallocated. Now I'm on line 10 again. But this time, hey, I think I can do the print now because it's just telling me to print a value of 6. Okay, that's fine. I'm just going to print a value of 6 to the screen or the printer, whatever. And I'm done with line 10. I go to line 11. Line 11 looks up post or the return line number, tells us to go to continue execution at post. And we have no use of column C at this point. Mark it as deallocated. And we are done with the entire trace. Are there any questions about this?
Like a graphical tool that can do this for you?
Yes, it is called your mind.
I just came here to rent video games.
Don't you like that, the cartoon? I mean, it's like, wow, so profound. Okay, but this is what it is. I mean, this is the illustration of how to use the return statement. And this implementation of factorial is the most concise way to express factorial. Let's take a look at new blocks here. It's still working. That is not encouraging. Going to stop it here. I think it might have to do with some leftover cookies. So I'm going to go delete. Uh-oh, that's not a good sign. Oh, I'm still recording, so the drive is still working. It's just that the browser has stopped working. Okay, let's close that and start it all over again. New blocks. Much better. All right. what I want to show you is an app. It's called Game Timer because my kids, they like to play video games, but I don't want them to play too much video games, during a school week. So what I do is I'm writing an app so I can tell them how many minutes they can play video games for a day, and they can basically just start and stop the timer until they run out of time. Okay. But I also want to add a feature, which is a session, because they want to chop it up into multiple sessions. They don't want to use up all the time at once, so they want to chop it up into like multiple sessions. So each session has its own, amount of time. Okay, it sounds really simple, right? It's just a timer, countdown timer. How difficult can it be? Okay, you can specify, a daily, allowance. Then you can, out of that allowance. Out of the remaining portion of that allowance, you can specify, how many minutes to allocate to one session, and then out of that allocation, once you start the timer, the remaining portion will tick and represent, okay, you got this many minutes and seconds left for this particular session, so they can plan ahead of time. Doesn't sound very complicated, does it? Let's take a look at the source code. And this is graphical. This is entirely graphical. And you can see from the scroll bar here, this is the program. Okay? Not exactly simple. Okay? And it kind of goes on and on and on like that. All of this code just to make an app like this to work. Okay, now I can even show you how the app works, without using an actual phone. So let me show you how the app actually works, just so that you know what type or how much programming is involved just to get a timer app to run. Okay, so let's see. Let's see tools. What I'm doing right now is I'm starting a Android virtual device, which is a virtual machine basically, and starting this one. And when that is launching, I'm going to use a different tool to upload the program. And I'm already in the right place here. So in App Inventor, the way you build your project is you click Build, and then you can download the APK file that you can install on just about any Android device. All of this work is being done remotely in the cloud. So as I make changes to the program, it is automatically saved in the cloud, just like when you use Google Documents or Google Drive. So it's pretty handy. I can actually write the program on one machine and then move on to another machine, just log into my account, and I can continue to work on my program. So this way I'm downloading an APK file, which is the format that you use to install an app on Android platforms. I switch back to my command line program here. So I do adb install -r. That's basically a remote debugging tool, so you can actually use it to debug not just a virtual device, but also to debug an actual Android device connected to your computer by USB or Wi-Fi. So it's pretty handy. So I'm going to install the app that I just downloaded, gametimer.apk, and it shouldn't take long. All right. That's taking a little bit longer than usual. I'm a little bit concerned about, but it's still recording, so I'm not terribly concerned. But it should go a lot faster than that. Oh, okay, I know why. Because the Android virtual device is still running. I normally do this in Classroom 126. And I think the PC in that classroom is significantly faster than the one that I have here. And that's why there's a big difference in terms of how long it takes for the virtual device to start up. Okay, finally. So this is really cool because if you don't have an Android device, you can still develop applications for Android because you can just emulate the device that you will be using. Success, great. Okay, this is really slow. Normally it's a lot faster than that in the other classroom. Okay, so now I'm getting to my applications. Come on. All right, so now we have game timer. All right, so this is the actual app. I'm not fully done with this program yet. So right now it's just hard coded to a daily allowance of 1 hour, and then each session is up to 15 minutes. And I click the start button, and you can see the remaining time just continues to count down. That's it. Okay. Now, but it does have one really cool feature. The really cool feature is if I accidentally press the back button, which I expect my kids to do, then it will say, oops, I lost the timer. I guess we'll start from the beginning again, and now I get a full hour again, right? Well, not quite, because Dad knows about that sort of thing. So when you load the application again, it loads how much time is remaining from the last time. It does not lose track. And if you start it again, it would just start, it's as if, we never closed the app to begin with. Yep.
So they have to manually press start. So they have to manually press start.
Yep.
So you trust them?
Well, because they have to be running the app, next to the computer. I can check.
Oh, I thought it was a phone. Like you had timed them with their phone. So that's what.
I can tie this into my router too. So if they don't start, if the router does not connect into the network, or disable the programs or something like that. Hey, I can make some money with this app here. Yep.
Is it using the operating system clocking system, or is it the computer inside clock? What I mean is
Everything is emulated, which means as far as the app is concerned, it thinks it's running on an Android device, but the Android device is an emulation, is a virtual machine. So that means it's everything boils down to actually just this box here.
Yeah. What I mean is, would they be able to alter the remaining time if they change the clock on the desktop?
Yeah, they can. Yep. But the app has a feature. Well, I haven't implemented that yet. I can make this app send an email to me whenever they make changes to those times, so I can know exactly when they make some changes to what time. Yep. But even without those features, just for counting down and be able to remember where we left off, in the first place, you can see. Okay, let me just close this app here. You can see the complexity of the program, just given that it is just keeping track of time. That's all. I'm zooming out a little bit so you can see or have a better idea of the size of the program itself, just the way it is. The reason why it is so big is because natively, App Inventor doesn't know how to parse even numbers. In other words, you can give it, in a text box, you can specify, okay, this is what you saw earlier, 15:00. It doesn't know what that means. So I actually have to write the subroutine to first chop it up into 15 and 00. And then after that, I have to say, okay, 00 refers to the number of seconds, 15 refers to the number of minutes. I have to multiply 15 by 60 plus 00 to get the number of seconds. So it takes that much code just to parse the input. Now, creating the output is the opposite. Okay, because internal to the app, it is actually measuring time in milliseconds, which is a thousandth of a second. I have to convert the number of milliseconds back into this format before it can display in the app. So just for that purpose, it's taking up quite a bit of code already. That's what we are running up against when we are writing programs. Is just little simple things that we think, hey, this is easy to do. it's not so easy because the user input and stuff like that actually takes up a lot of logic. Okay. So are there any questions? Any comments about, I just want to write some game? Because writing games is even more complicated. It is a lot more complicated than just that. Yep.
Well, since everything on there is going like out as well as down, how are you supposed to read like an order to it? Like free floating.
You just have to kind of remember where things are in this map here.
Okay.
That's one downside of graphical programming is it's not linear. It's actually it let you put your code anywhere. Now I can arrange it in a certain way. I'm taking a big risk here because I won't remember where the blocks are, because when you do rearrangement automatically, I'm at the mercy of the engine here. So this way it is arranging everything just vertically. Or not. Oh, okay. This is actually horizontal. Did I click the wrong button?
No.
Okay, now let's try that. Since I'm lost anyway, it doesn't matter anymore. Okay, so but you can see but the problem is, what if I want to make this click event logic a little bit bigger? It's going to overlap with the next one. Then I have to move everything to make it look right. And that is the issue of graphical programming, is it doesn't move things around automatically, or it's not easy to make an interface that would move things around automatically. Whereas if you're just using plain text, no problem. Put a new line and everything is going to shift down by one line. And then the other problem with this type of programming is everything is done by drag and drop, whether you like it or not. So there's a lot of dragging and dropping, where normally you would just be typing and using the backspace key. Now you have to drag and drop and delete and do all sorts of stuff like that. But nonetheless, it is a very interesting way to start programming, because the barrier, the energy barrier to start with something like this is really minimal. It's you cannot make mistakes, because you just go to a block here and drag it and drop it and put it into place. If it doesn't belong to a certain place, it won't click. So you cannot write code that is incorrect.
Where did you get that emulator again?
The emulator, you can go to the Android website itself. Go to android.com and you can download their SDK, Software Development Kit, and it's inside the Software Development Kit. I think it's about 90 megabytes to download. It's not too terrible. Yep.
So before you can add this to the App Store, does MIT analyze the whole program?
Yep. Yep. It has to basically quote unquote compile the entire program written this way, and it has to generate the Java code and do all the other thing to prepare your app to become an APK file. Once you have the APK file, you have to register with Google, pay $25, as a one-time fee to become quote unquote a developer, and then you can have your own store. If you're not going to sell your app and charge money for that, that's all you need to do. Just pay $25 and you could become a publisher. If you want to charge money, then you also have to go through the other process so they can establish a financial link to your account, so that if people want to buy your app, they have to know, who am I paying? And then Google has to keep track of how much money you have made, because it has to report that to the IRS and so on and so forth.
And like all of these are open source, right?
And yes, App Inventor is open source. Android is open source as well. Yep. And I think this is why Apple is maybe missing out a little bit here, because in order to become an Apple iOS developer, I think you have to pay $100 per year.
Per year, and you must have an iDevice on which to code on. You can't do it on PC.
There's no emulation?
Xcode?
Yeah, Xcode.
You must use Xcode, and you can't. I've tried to find it. Maybe there is one, but I haven't found an Xcode emulator.
Okay, and it's not a standard language either, because in order to program iOS, you have to use Objective-C, which is neither C nor C++, nor Java.
They also implement Cocoa inside.
Say again?
They also implement Cocoa.
Yep,
Yeah,
they have
it's-
Cocoa on it.
And
doesn't Apple inspect the code before releasing the app?
I think they just have they reserve the right to whether let your app be published or not. Even if it is published, they can pull it from the market if they choose so, and they don't have to explain why they're doing it.
When I was working there, when they first put out App Store, and they started pulling stuff down and doing that because people were putting up a lot of porno apps and stuff like that, and we were getting a lot of calls from parents and stuff. I was like, it's kinda
Okay.
awkward.
Well, but they also pull apps, that are
Yeah, of course, there's
for
other those
many
too,
other
yeah.
reasons. They just reserve the right to pull the apps, and they don't have to explain it. Whereas in Android, has they make you read a policy, and there are certain things you definitely do not want to do. They even let people do quote unquote adult apps. You just have to mark your app accordingly, and and indicate what is whether it's mature, whether it's basically equivalent to PG, or whether it's for general public. As long as you indicate it correctly, Android doesn't care. I mean, you just have to indicate what kind of app it is. So if it is not malicious, you're not intentionally trying to bring down the network or hack into a device, they usually just let it go. I mean, it's like, whatever. Yep.
So with Android, can you use like a malicious program for ethical use? Like a keylogger for your kids?
A keylogger for my kids. That's an interesting question, because if in doing so you are bypassing security features that is built into Windows, then I'll be violating the DMCA. The DMCA is the Digital Millennium Copyright Act, which basically says you cannot use any means to try to defeat a protection security mechanism of whatever software. So because of that, trying to bypass something to do a keylogger app can be a violation of the law already.
How about Linux distributions?
In Linux, you can just hack the kernel, right? The source code is there. I mean, you just say, okay, for all key events, log it and then send it to this IP address. You're done. And you just tell your kids, okay, you have to use Linux. But I can't run this software using Linux. Yeah, you can run Minecraft. That's good enough. Yep. So the DMCA does not apply to Linux because it's open source. Once it is open sourced, you have the source code, you have the permission, the right to change it, and therefore you can put any changes into it if you want to. Yep.
Talking about the law, how does it work if you do publish an application abroad and you commercialize it abroad? Where it defeats the law here, pretty much, like keylogging and all that. I'm pretty sure there's a mechanism, a legal mechanism where it defeats like hacks and keylogs and everything. But say you make an application, an Android application, you commercialize it abroad, and it actually affects here. Like people will download it here, and it will hack into their system. How does that work as far as law goes?
I think you can get into legal problems, like that. Even if you're just logging within your own app, you can potentially get into trouble. You have to read the entire, policy on the Android, website for the developers, because in their policy they really outline, what you can or what you should and should not do in your app. Anything that can involve, privacy and security, they have very specific clauses to make sure that you are not doing anything that you're not supposed to.
But that's
Or you disclose the fact that you are, logging things and sending it to mothership.
But what I mean, that's in US, right? Like the law will apply in US.
And many other countries.
Oh.
Yep. Yep. But this is a really cool and interesting way to write apps. You don't have to learn, the syntax of Java or C++ or anything like that. Anyone can get started. The designer, which is designing just the screen portion of your app, is for the most part what you see is what you get. Okay, it's not entirely so, but it's close enough for a lot of purposes. And I think we have learned enough concepts in this class to actually write a lot of apps already. If you go to blocks, I know we are running out of time today. If you go to control, we have conditional statements. We have the loop here, while, test, do, which is our pre-checking loop. They do not have any post-checking loop, so that's actually missing from App Inventor. And then it also has subroutines. Go to procedures, and we have our subroutines. It has both subroutines that can return a value, which is the one with a result, and also subroutines that do not have a return value, which is the one with only a do but without a result. Okay, and all of these can take parameters with one exception. It cannot have pass by reference parameters. That's the only limitation. Okay, there are ways to get around it, using lists, but that's kind of like a more advanced, topic. But for the most part, everything that we talked about here, if you go to variables, you can have global variables. You can also have local variables. So those concepts are already present in App Inventor 2.0. This is actually the 2.0 version of App Inventor. Version 1.1 was started by Google, and then they abandoned the project. MIT picked it up and continued the development. Yep. Well, we are running out of time. I'm hoping that you guys might try this out. I mean, this is free. I mean, if you have time, why not?
Professor?
Yep.
Are you teaching